Today we got a 2012 Camaro. Complaint is that it has some harsh shifts, particularly when taking off. So giving it a little test drive, see if we can get anything to act up, and we'll go from there. So the first step to any transmission diagnostics is to check the fluid level. For this, you're going to want to consult some repair information because there are many different ways to check fluid. Some manufacturers have a dipstick, some want you to check the vehicle while it's running, some while it's not running, and most of them, they want you to have the fluid at a very specific temperature. And if you have the temperature off, your reading's going to be thrown out the window. But not only that, you want the level to be okay, and you want to look at the condition. If you see a whole bunch of shiny metal pieces in there or that fluid looks like garbage, then you're pretty much done. It's time to drop the pan and see if you have any debris in there, because most likely you've had a catastrophic failure. So here we're underneath the car and we can see a little bit of transmission fluid here on the oil pan. We can tell it's transmission fluid from the color there. So if we keep looking back, we see that it looks to be originating from that plug right there. So I cleaned up all the leaks, sprayed it all down, made it nice and clean. And I'm laying down some cardboard. So now we're just gonna let the vehicle run for a little bit and see if we have anything on the cardboard or any leaks present. So that was a quick and easy one. That transmission is going to have to come out so that the seals can be inspected and replaced. Now let's say your issue wasn't that easy. Well, the next thing you're going to want to do is a full DTC scan. If you can't do a full system scan, then at the very least you're going to want to check the ABS, engine, and transmission for codes. Transmission for obvious reasons. Engine and ABS are important because they have a lot of interconnected systems that can affect the transmission. This vehicle, for example, had an issue with the transmission where it would have a very delayed gear shift. After scanning the modules, we see that there's a O2 heater circuit code. Well, fixing that heater circuit code ended up fixing the transmission. Reason for the transmission shift is that the transmission was trying to heat up the oxygen sensor in place of the heater, so it held the gears for longer, holding at higher RPM so that the oxygen sensor would operate. The next thing you'll want to check is TSBs. This, for example, is a TSB on the 6L45 that had a harsh garage shift, and a lot of people were replacing transmissions and differentials to fix this issue, when it turns out all you need to do was put some Loctite on the output spline. And another thing you want to check are for software updates. This 2016 Honda Pilot was having an issue with delayed shifts, and the fix ended up being a software update. This is something that you could have replaced the transmission and you would still have the same exact issue. Now, if you get no DTCs, you're going to want to get as much information as possible. One of the first questions you should be asking is, did this issue develop suddenly, or is it a more gradual issue? Gradual issues are going to point to more mechanical wear like burnt clutches, while the sudden issues are going to point to something usually electrical or hydraulic. So for the next example, I had a 2008 X5, and the complaint with this vehicle was very jerky upshifts. And after talking to the customer, it seemed that the issue had developed gradually over time and that it was happening in all gears. So we could rule out that a single solenoid was the issue and that the valve body was likely okay because it would be unlikely for the valve body to be scored on all bores equally. So what I ended up finding with this one was that it was dropping line pressure, not from the valve body, but from the connection between the valve body and the transmission housing itself. There's a little rubber seal, and that was worn out, and that was causing the fluid pressure to drop across. With this next case, I want to talk a little bit about solenoid testing and how to isolate which circuit your issue is on. So the vehicle here is a 2017 F59. It's a strip motorhome chassis from Ford. And the complaint was that if you put the vehicle in drive, nothing happens. If you wait about 10 seconds with it in drive, the vehicle will suddenly slam into gear, but you're now in fifth gear. Basically, it's a limp home strategy. So here I have a capture on the IDS tool. This is the Ford factory tool. And we can see that when the shift solenoid A, SSA, starts ramping up, that's when the vehicle was put into drive. We can then see that all the way down the line, 10 seconds later, the vehicle finally shifts into fifth gear. Not one, not two, but fifth. So we can now pull up some service information and see what's going on here. Reading through our description and operation of this transmission, we can see that to obtain first gear, shift solenoid A needs to be commanded on to apply the first, second, third, and fourth clutch. That is all one clutch that controls all those gears. So we can pull up a shift solenoid chart and we see that in first, second, third, and fourth, shift solenoid A is on, and then it finally turns off in fifth gear. So that forward clutch is not going to be engaged in fifth. So how do we know if our issue is with the shift solenoid or if with the clutch itself or in the valve body? Well, we can pull up a wiring diagram so we can get some information on the shift solenoid so that we can test it first. To test the shift solenoid, treat it like any other solenoid in the car. Start with a resistance check. If it's out of spec, the solenoid's likely faulty. You'll usually find the spec and service information, but if not, compare it to another known good solenoid of the same type. Some solenoids are normally high and some are normally low, so be sure you're using the correct reference. If resistance is within spec, that doesn't mean the solenoid is good. It could be mechanically stuck, and that's where current ramping comes in. Using a current clamp and an oscilloscope, you can observe what's called the pintle bump, a signature spike that shows the magnetic core is actually moving. Now, you're not always going to see this depending on the control type of the TCM. If you have a pulse width modulated solenoid, then it may be unlikely to see this. Another basic check is the click test, and you've probably done this before. This is the audible click you hear when a solenoid energizes, and it's the pintle physically moving. But even if the solenoid itself is good, it doesn't work if the control module isn't commanding it. So always verify that the solenoid is being powered and controlled under the correct conditions. And to do this, you can, if you don't have a scan tool to bidirectionally control the solenoid on and off, you can either monitor it while you're on a road test, or a lot of vehicles that have manual shift modes can allow you to engage solenoids on and off by selecting the correct gear. And if you have a shift solenoid chart handy, you'll know which gears to engage to turn on which solenoids. And back to our F59 case study, we're tapped into the circuit for the shift solenoid A. We have in blue the current for that solenoid. In yellow, we have the solenoid control. So this is going to be ground side control. And in green, we have the solenoid feed. We can see that the ground side control is varied by the TCM, but we can see that the TCM is in fact controlling it and that the current is ramping. We don't see any big spikes in the current indicating a shorted coil. Then if we wanted to compare it to another solenoid, we could use our current and voltage measurement and plug that into Ohm's law, and we could calculate the resistance of this solenoid, and we can do that for the other solenoids and compare. But that's not necessary here. We were able to, once we were in this circuit, I could give this solenoid full ground at the control side, and I could physically hear it clicking while the vehicle was off. No, so I now know that the solenoid's working properly and that there is no mechanical issue there. So now the valve body had to be dropped for inspection, and while it was dropped, I decided to perform an air check on the forward clutch. This is not the exact transmission, but when I injected air into the forward clutch, I heard air hissing out, indicating that the clutch pack was not sealing. And after informing the shop of this, they decided to replace it with a reman transmission, and that fixed the issue. Another key area to check when diagnosing transmission shifting issues is the temperature sensors. After a cold soak, scan all temp sensors, coolant, transmission, intake, and verify that they're all reading roughly the same. If one reads abnormally high or low, it can throw off the shift strategy and affect the overall drivability. Also, don't forget to look at the speed sensors. A faulty wheel speed sensor or a vehicle speed sensor, input shaft speed sensor, output shaft speed sensor can all cause abnormal shifts or even prevent shifting entirely. I've seen multiple cases where a transmission was nearly replaced only to find it was a bad speed sensor.